The purpose of today's quiz was to determine whether inversions, duplications, deletions, and translocations have an effect on the amount of DNA content in a nucleus. So to determine this, let's look at a couple of idealized chromosomes. We'll call them chromosome 1 and chromosome 2, and we'll imagine that each of these chromosomes has a number of loci. We could imagine that each of these letters represents a unique DNA sequence that we have used as a FISH probe so that we know their relative order on the two chromosomes. And we could imagine a series of stages, say, through time, where we look at these chromosomes, maybe these are different species, for example, and we see differences. And here we might be looking at a different individual or species. And again, the letters just represent the locations in the genome on chromosome 1 or chromosome 2 of different loci. So we'll do a couple more examples, and then we'll analyze these data. The last chromosome we'll look at there. First, let's try to identify different major chromosomal rearrangements that have occurred in each of these steps. So we'll call them step 1, state 2, chromosome 3, chromosome step 4, and the 5th version or step. So what has happened between states 1 and 2, or steps 1 and 2 in this chromosome's life? Well, it looks like the only difference between 1 and 2 is that locus B has been removed. That looks like evidence of a deletion. And then what's the change between 2 and 3? Well, D and E are no longer on chromosome 1, but now they're present on chromosome 2. So this looks like a translocation, where loci D and E have moved from one chromosome to another. And then from step 3 to step 4, the order in step 3 was F, G, E, D. Now the order on chromosome 2 is F, E, G, D, which makes it look like the loci E and G have flipped their orientation, or inverted. This is evidence of an inversion. And then in the last step, well, there was only one copy of locus C on chromosome 1. In step 5, there are 2. So that looks like a duplication. So it seems like, in this case, to go from the original observation of state 1 of these chromosomes to the current observation, chromosomes represented in state 5, requires one deletion, one translocation, one inversion, and one duplication. Ultimately, then, the question was, which of these types of chromosomal rearrangements change the DNA content in a nucleus? Well, the deletion caused loss of B, part of the chromosome. So yes, deletions do cause loss of DNA content. Did the translocation? Well, loci D and E moved from one chromosome, chromosome 1, to chromosome 2, but this did not change the total amount of DNA in the cell. It just changed its location in the cell, in the nucleus. The same is true for the inversion. these DNA sequences G and E still exist after the inversion, they're just in a different order. So inversions don't usually cause a change in DNA content. Finally, a duplication, as its name suggests, increases the amount of DNA in a cell.